Hello guys, for today's video, I'm going to teach you about the continuity of a function and a function interval. Okay, so what is a function interval? A function interval is said to be continuous at f is equal to c if there is no interruption in the graph of f of x at c. There is no whole jump or gap at x is equal to c. So, upon tracing the graph of a function, you are not going to leave your pen of x is equal to c. Once you leave your pen, it means that the graph of a function is discontinuous at x is equal to c. So, in that, it means that while you trace your pen, just like that, you cannot have a gap like there is a line up there because there is a gap here, and that is how the definition talks about. Now let us try to more figure out what is that mean. So we have our example here. So our example is f of x is equal to 3x minus 1 is if it is a continuous at x is equal to 1. So it means x is equal to 1. So from here up to 1. Right? So, titignan natin kung function ba tong given function natin. So, using our pencil, tracing it from x is equal to 1 to y is equal to 2. So, from here up to there, as you can see, you cannot, there is no holes, jumps, or gap while tracing the graph. Therefore, we can say that this function, f of x is equal to 3x minus 1, and interval of x is equal to 1, is a continuous. Okay, so that is how you will determine if the function is continuous in a given interval. Now, for our next example. For our next example is, we have only given as x is equal to 1. This is our interval. So now we'll try to trace this one on our graph if it is a continuous or not. So x is equal to 1. Nandito siya, 'di ba? X is 1. So now let us try to trace it if there is a gap to x is equal to 1 to y is equal to 2. Okay? So, while tracing it, as you can see, there is a gap, right? Gap from what interval? From the x is equal to 1 to x equal to 2, right? Kasi pag tinrace natin siya, meron talaga siyang gap, merong putol. So, it means that this given graph is discontinuous. Okay? So that is how you trace it when you have given only one interval. And now, we will proceed to our proper discussion, which is all about the continuity of a function and interval. So, we have types of an interval. So, the first type of our interval is the finite interval. So, finite interval, these are the interval whose endpoints are bounded. Okay? So, here we have the interval notation. So, we have this parenthesis. So, this is called as the open interval. It means that A and B are not included, or we can say that x is greater than a but less than to b. Okay, so see here for our number line sketch. So for our number line sketch, we have, as you can see, there is open shaded, not a shaded part, it is an open. So this means that A and B are not included in our boundaries. Now let us proceed to our second notation. Okay, this is also called as the combination. Combination. It composed of an open and closed interval, or either side of it can be like. Okay, so this is a combination notation. So where A is not included but B is included, because if you can see a bracket like this, it is a closed bracket. It means that all the values that inside it are included. Okay, so as you can see in our sketch, that A is open shaded but B is bold shaded, right? Okay, let us proceed to the second. It is also a combination. It is also a combination. This one is an open interval. So this one and this one are combination. So in this part, as you can see, A now is included, but B is not included. So in our sketch, as you can see, it is whole block here. In our A, it means this one, A is included. But pagdating mo sa B, is the B is not included right now because it is open. Okay? And our next interval notation, this is called as the closed interval. This one, both A and B are included. Okay, as you can see in our sketch line, all the values of A and B are shaded. So it means that are included to our boundaries. Now let us proceed to called as the infinite interval. So in infinite interval, wherein there are intervals with at least one unbounded side. Okay, so this one is called as the open left bounded. Okay, it means that the left side of the interval is or has an endpoint. So let's say it is A up to, right, A up to positive infinity, right? So A up to positive infinity. So for our next interval, it is also called as the open right bounded, wherein from B up to negative infinity. Okay, so next notation is called as the closed left bounded. So wherein in this case, it is the same with the first one, but in this time boundary are included, right? So it means that this A is included now up to positive infinity. Okay, for our next notation, B up to negative infinity, wherein B is included now up to negative infinity. Okay, for our last notation, it is called as the unbounded interval, or it is also called as a set of all real numbers. In this case, there are no boundaries at all. So it extends from the negative, from here, negative infinity, up to positive infinity. It means that we are considering set of all real numbers for all values of x. Okay? So that is the types of interval that we can use that in our examples. Now, let us try to determine the continuity on the given graph in each of the given intervals. Given the graph, okay, let us try to identify whether the interval is continuous or not. Okay. So for our first example, we have the interval, a closed interval of 1, 2. Okay? So this is a closed interval, right? We have boundaries, and the boundaries are included to identify if the graph is continuous at the given interval. Then we have to identify first where are the boundaries. So the boundaries, we will start from x is equal to 1 and x is equal to 2. Okay? Take note that all the boundaries are included in the graph. So, based on our graph, if we use this one, this is open shaded, right? Open shaded. It means that it cannot satisfy our interval. So that means we will not use this one. But this one is a shaded. So it satisfies our interval, which is 1 to 2, because it is included. So now we will use the shaded part of this graph. Okay. Now, we will trace our graph from x is equal to 1 to x is equal to 2. Based on our graph, while tracing from between y, this one, y is equal to 1, from here, up to y is equal to 2, up to there, right? So, because our interval is 1 and 2, so 1 and 2. So, from here, up to there is a gap, right? There is a gap of our given graph. So, therefore, we can conclude now that our function is discontinuous at the interval 1 and 2. Okay? So now let us proceed to other interval. And we will also use this graph. Okay. So our next is this one. Open interval 1 and 2. So this one are open intervals, right? So, but 1 and 2 are both not included. Okay, but same thing, we have to identify where is the x is equal to 1 and x is equal to 2. because those are the boundaries. But we have to take note that all those boundaries should not be part or they are not included when we will check, because it is an open interval. Okay, so now because it is open interval, we will use the open shaded this one. Okay, now we will trace our graph using our pencil while tracing. Okay, while tracing from x, okay, from here to there, to here. Okay, so while tracing it, okay, up to x to 2, okay, as you can see, there is no gap or hole or jumps. Therefore, this function is continuous and open interval 1 to 2. Okay, so that is how you determine the continuity on a given interval. Now let us proceed to another example. For interval, open interval 1 and close interval 2. Interval 2. Since x is equal to 1, okay, x is equal to 1, this one should not be included. Therefore, we will use the open shaded, this one. Okay? While tracing it from x1 to x2, here to there, is also there is no gaps or hole or jumps. Therefore, this function is continuous on interval, open interval 1 and close interval 2. Okay? Now, let us proceed to a more difficult notation. Then, we will use this graph. Okay? So, for interval, we have our unbounded. We'll use negative infinity to positive infinity. This one is unbounded, right, in the notation. In this part, only the real numbers. Okay? So, we'll use the x as positive infinity, and the other x is also positive infinity. Okay? Are included or. Therefore, we will use the all values of x line. Okay, so now let us try to trace it if there is a gap in the graph. Okay, so this is a positive infinity, all real numbers, so any part of this x, but it is a positive, so from 0 to their infinity, that line, and so on. We will trace it, okay, from this one, okay, this line and this line are included to our graph. Okay, so as you can see, this part, because when you trace it, there is a gap, right? There is a gap between these two, the two, which is the y is equal to 1 and y is equal to 2. So therefore, our given function interval from unbounded negative infinity to positive infinity is discontinuous. Okay, so that is how you determine whether it is continuous on the given interval. Now let us proceed to the continuity on a closed interval. Okay, so what is continuity on a closed interval? A function of f of x is continuous on a closed interval a, b if it is continuous on open interval a, b. Okay, and the notation of formula for that is a log f of x while x is approaches to x to the positive side is equal to f of a, and log of f of x is x is approaches to a to the left side, that is equal to f of a. Here are the three conditions that must be satisfied to say that the function is continuous. So the first one is check if continuous on the open interval a and b. The second one is the limit of f of x is approaches to a to the right is equal to f of a, and the limit of f of x is approaches to the left is equal to f of a. And the last one is limit of f of b. Limit of f of b is equal to f of is approaches to x to b, approaches to b to the left. Now let's try our example. For our example, determine whether the following function is continuous in a given interval. F of x is the square root of 9 is equal to x raised to 2 in the interval -3 to 3. Okay, so based on our example here, okay, our -3 is our a, and our our 3 is our b. So we can rewrite that as a is equal to -3 and b is equal to 3. Okay. Now let us solve it for our first condition, which is this one. Check if continuous on the open interval AB. Okay. So since it is now open interval, the -3 and 3 is not included, right, in the value of x. Therefore, we will use the table of values x and y. Okay, so we will use only the -2.5, -2, 0, 2, and 2.5. Okay, so why we will use only the 2 and 2.5, not 3? While we can also use that, but for the sake for our example and for us to have a lesser time to solve it, then we will use -2.5. So how will we find the value of our y? So to find the value of y, we will use as this one as our x. Okay, so for our example, we have the square root of 9 minus x squared. So the x here, we will substitute it by negative 2.5 raised to 2. Okay, so now let us solve it. So negative 2.5 times negative 2.5 is 0.5. So that is 6.2. So we have 6.25 minus 9. Now, the next is 9. Okay, 9 minus 6.25. So we have square root of 2.75. Now, what is the square root of 275? So, the square root of 2.75 is 1.66. So, now we can write here as 1.66. Okay, so that is how you will find the value of Ry. We are only substituting our value of x here to the assigned values of x. Okay, so also in the other part of this, to find the value of y, we'll also substitute. Example for this is the negative 2. So we will only substituting it to negative 2. Okay, negative 2. And then the answer of that is 2.24. The 0 is 3, and 2.24 and 1.66. Okay. Now let us now as you can see, okay, on of our table, our x is have a value on it. Okay, di ba? Meron tayong mga value. So we can say now that our open interval negative 3 to 3 is continuous. Okay, in an open interval. It means that our first condition, which is to check if continuous on the open interval AB is satisfied, which is it is continuous in our example. Therefore, we now can proceed to our second condition, which is the limit of f of a. Now, f of x. So, we can write that as limit f of x is approaches to a to the right is equal to f of a. Okay, so that is our formula. So now we're going to substitute it for, because it's a, diba? So our a daw is negative 3. So we will use the negative 3 of our f of negative 3 na yan. F of negative 3 is equal to the square root of 9 minus the quantity of negative 3 raised to 2. Okay. So now we're going to solve. So square root of 9 minus 9, because negative 3 times negative 3, that is 9. And that is simply equal to 0. So our f of negative 3 is equal to 0. Therefore, the limit of f of negative 3, we can say that it is continuous at the right-handed of the limits of -3. So, because it is continuous, because it has a value of 0, now we can proceed now to our last condition, right? Which is the limit of f of b, x approaches to b to the left. So since RB here, wait, we will write first our formula before we proceed. So our formula is, okay, this is our first condition, second condition, and this is our third condition. So our third condition, the formula is limit of f of p, x is approaches to p from the left. Okay, from the left. Now, RB is 3, right? The first we are going to do now is to substitute the limit of p by the value of b, which is 3. So now we have f of 3 is equal to the square root of 9 is equal to the quantity of 3 raised to 2. So, square root of 9 minus 3 times 3, that is 9 also. So, the answer of this is f of 3 is equal to 0. Okay, now, we will proceed to the left side of the limit of b because this is the right side of b. Okay, so now we will proceed, which is the limit. Okay, we will use this formula now. The limit of square root of 9 minus -3 squared is approaches to, x is approaches to 3 from to the left. So, we will substitute it. So, the limit f of -3 is equal to simply as 0 because based on our condition number 2, it is also similar. And also, the computation of that, ang makukuha din natin is yung 0 dito sa limit of, as a third condition natin. Okay. Therefore, the limit of f of 3, x is approaches to 3 to the left is equal to 0. So therefore, we can see that it is continuous in the left-handed of the limits of 3. Now that our three conditions, okay, these three conditions are all satisfied. Therefore, we can conclude now that our given function is continuous on the interval, closed interval, -3 and 3.